We're going to talk all about Python today, building cybersecurity tools, all about solving problems. Took a quick poll of everyone. Everyone's done something with programming before. We're going to start with some statistics about why this topic. 75% of security professionals report that automation reduces the time spent on manual security tasks such as log analysis and vulnerability scanning. And quick show of hands, how many people hate doing manual tasks over and over again? Okay, some of you like it. All right, all right. I'm not going to judge. All right. 68% of organizations have seen productivity improvements through automating security processes. And an estimated 40 to 45% of cybersecurity tools are written in Python. So, one of the reasons we talk a lot about Python is because a lot of tools are written in Python. It's very accessible. Today, we're going to cover Introduction to Python for Cybersecurity. We are going to cover the basic syntax of Python. So, if you've never done any programming before, never seen code before, you will only be a little lost. So, it's all right. We're going to try and go through it as quickly as we can. Then we're going to talk about once you've created Python scripts to solve those painful everyday problems, how you can make your own cybersecurity tools out of them. Specifically, we'll be making command line tools. And then we're going to say, you don't want to write those every time, every day, right? That could take hours. There's not enough ducks to talk to solve those programming problems. So we're going to look at how AI can help us write those cybersecurity tools for us. And then we're going to look at actual examples of, I have a fun video to show. It was going to be live, but live coding demos never work, especially when I don't have my computer and I have the university's computer, and they don't like me writing malware on their computer anymore. Enough said on that topic. So what is Python? Python is a high-level programming language created by this guy, whose name I can't pronounce, in 1989. It was created to be simplistic and easy to use. So it's been around for a long time, over 30 years. We're getting close to 30 years. So why are we talking about Python for cybersecurity? It's a dynamic programming language. That means we can utilize it and we don't have to compile things. We can write code and it will just happen. We don't have to worry about a lot of build tools, not a lot of processes. Anyone, as long as you have Python installed, which is installed by default on most Linux operating systems, can pick a text editor up and start making Python code. It's very easy to learn and utilize, as we'll see, and you can rapidly prototype and deploy code. Can't promise you'll get people to actually run it because you shouldn't run untrusted code you haven't looked at, but we can deploy it pretty fast. Now, there's a lot here when we talk about Python. So we are going to cover maybe 15% of this today. Probably not in depth, but we have Python and there's Python libraries, there's different tools, IDEs, there's control structures of programming that kind of go with every programming language. There's applications, create web applications. There's data science and machine learning. We can use Python to create AI, and we can use AI to create Python, and we can use AI to create Python that creates more AI. And it can be a very complicated, confusing environment, but that's okay. You don't need to worry about any of these advanced topics because we're not going to cover them today. But I do encourage you, if you enjoy what we're about to go through, to dive deeper into Python and making larger and more helpful Python applications. So let's talk about some of the use cases, because the best applications, just like the best products, solve a problem. So when we talk about solving cybersecurity problems, what is something that from a offensive security, we're talking OSCP, penetration testing, what is something that's a tool created in Python or a problem that could be solved? There's lots of tools that have been created. You'll find them online. You'll see port scanners. You'll see a lot of different Python tools. Lots of different tools are built using Python and Packet, very popular library used for man-in-the-middle attacks. automation. You can automate your pen testing activities and reporting. There's a lot of use cases. So lots of tools are created in Python, lots of automation, and lots of reporting. Defensive use cases. So we have automation again, but notice I don't have tool creation here. And you may wonder, well, can't you build defensive tools in Python too? And the answer is yes, but you probably don't want to. If Nessus does a really good job at vulnerability management, you are not likely to build the next Tenable. It just won't happen. You don't have the resources to do it. But what you could do is use Python to tap into Tenable's API, create a really nice Word report that gets sent to your vCISO every Monday that categorizes specific KPIs for your organization. So this is where, when we talk about defensive tools for Python, it's not about building new tools generally. It's we are automating and doing analysis on existing tools. We're almost always interfacing with some kind of API, whether it is utilizing with Nessus, utilizing with Nmap, or some other tool. Firewalls generally now have APIs too. So we can even sometimes close and open ports via an API call. There's a lot of cool things we can do with just a little bit of programming knowledge. So what is Python syntax? Python syntax are the way we format our code so the computer knows what we want it to do. And it provides us rules around how we type in our code. And if we don't follow those rules, the computer isn't going to be too happy. It's not going to understand what we want to do. Now, when we talk about syntax, typically we start by talking about variables. Now, there are a couple different variables in Python that we need to discuss, such as strings. Strings are just the sequence of characters that we have in Python. It's typically how we get input from an end user. We have numbers, which are our integers that don't have decimal points. We have floating points, which are anything that is 1.23 or negative numbers. And then we're going to hold off on lists, tuples, and dictionaries. And you might say, well, why do we have different types? Why does this matter? Well, every single type takes up a different amount of space in memory or RAM when you're running a program. In fact, numbers will often take up less than lists, for example, or strings. So there may be use cases where one type is used for the other. The other issue is that depending on what you're doing, if you can't add two strings together. So if you had one that's a string versus one that's an integer, it would cause issues. Now, this is all syntactical, but the key important thing you need to know, because you're not really going to type many things in the examples we're going to show today, is that these exist. And Python does a lot of this for you in the background. But there will be times that you will run into an issue where you have a string, which is a word or a string of characters, versus a number, and you may have to convert them. Now, lists, tuples, and dictionaries. We're not going to worry so much about tuples for the stuff we're doing today, but we are going to focus on lists and dictionaries. Lists are going to allow us to do lots of different analysis on any data we grab in Python. It's a way of structuring data so we can iterate through a list. We can look at every item in a list, whether it's a list of numbers, a list of people, or even a list of functions. Dictionaries are going to be generally how we communicate with web applications via JSON interaction. It's value and type pairs. And if this isn't making sense, that's okay, because we're going to look at some real examples. We just need to go through some of the basic structures. So moving on from variables, we have a couple other ways we can build applications. Typically, whenever you're building any kind of application program, there are three ways to control how a program executes. Sequentially, so it's just going through, okay, you wrote this here, the computer will keep going to each line that you write, one after another. You can do selection, where you can actually specify, hey, if this equals this, I want you to do this action. Otherwise, do this action. You're selecting based off a certain criteria. If you've taken a programming class before, you've seen this as if-then statements or if-else statements. And then you have repetition, where, hey, computer, I want you to run this over and over and over again until you get to this specific result, or until you've gotten through every item in my list. Python makes this really easy with lists. We'll see this in a moment, how we can do a for loop through every item in a list. Now, some of the syntax for if statements, this is typically how we see an if statement in Python. We're going to if, we're going to have a variable here or something we're comparing. We use two equal signs to check if something is equivalent. We're going to see if it's equal to high. In this case, we're just printing this vulnerability is bad. And in our example down here with if else, we want a little bit more. We can say if it's high, this is bad. If it's low, could be worse. So those are just two small examples. We also have the ability to do and or operations, which give us the capability to say, if these two things are together, you must have these two things to continue. You can do either this or this, and I want you to run this code. So this gives us a little flexibility in how we create our structures and programs. Now, moving on to loops. The way that we iterate over elements, we have a couple different ones. We have a for loop for every item in a list. A while loop, we can say while a number is 0, we want to iterate over and we're counting something. So you'll see a lot of while loops. A lot of times for most of what we're doing, for loops will work because we'll have a list or data type we're bringing in. We can break out of loops, continue loops, and go through a range of items. Now, the last thing for Python syntax, and so far, some of this should not be new. Some of you that are new to Python are like, man, Brandon, I don't really understand a word you're saying. That's okay. We get into examples. We're going to go through parts of it. So Python functions are a way for us to encapsulate any code that's reusable. It's another way that we can design our applications to be more modular and update it more. So we start with the definition. We put some parameters. A function can take something and give us output. And we'll talk about this a little more in a second. But when you think of applications, we should always be thinking, okay, what are the things that I'm giving to this application? What is it doing with the things I'm giving it? And what is it giving back to me? And as we design our functions, that's going to be the exact use cases for how we're going to build our own applications. All right, Python libraries. So Python libraries are reusable chunks of code. We use it with this awesome keyword called import, and it gives us the ability to do incredible things without writing code. Essentially, we're using other people's code, and that's what Python libraries are. They are other people's code packaged up in a way that is easy for you to write. In fact, you don't have to just import standard libraries or libraries off pip. You could even import your own Python files that you have just by importing that specific Py file that you've created. It's just someone else's code. A lot of times you'll see things referenced to the standard library. This is the library in Python that is built in, that comes with the language. And then you will install using something called pip, which is a software package manager to install more. I see some of you are like, Brandon, I don't know what you mean by accessible. This is really complicated so far. But Python libraries, let's talk about popular ones in cybersecurity. And this is where we'll start getting into some of the fun of this session. How many people here have ever used Wireshark? All right, so a lot of people. So if you wanted to use your own Wireshark or manipulate packets, you could create your own Wireshark-esque application using Scapy. And you might say, well, Brandon, why would I want to do that? Wireshark works great. Well, the thing about Scapy is it lets you create your own packets. Well, I'm a cybersecurity professional. I need to test, validate controls and defenses. Well, with Scapy, I can make traffic look like it's coming from a certain port or attack a certain port in a different way. So all of a sudden, hey, with a little bit of Python, I can now write some security tests using a built-in library. Requests is a library for interpreting different web pages. How many of you have ever thought before when looking something up, man, it would be great if I could capture this information on this web page and store it somewhere without having to just copy and paste or check news articles? Requests can do that. In fact, many of the scraping apps on the web utilize requests as their library. Beautiful Soap will clean up HTML and XML data. PyCrypto allows us to do Python to do cryptographic keys. So you'll actually see this used. You could, if you wanted to, and for all you at home, don't do this. People here don't do this either. You could create your own ransomware with PyCrypto. You could create your own encryption keys, encrypt files. Don't recommend doing it, but it's how the bad guys do it, right? They use programming languages too. Nmap. How many people have ever used Nmap? A lot of people. You can automate Nmap with Python, from the results to how you're parsing it to when you run it, and impact it for doing man-in-the-middle attacks. As I was saying, now that we got all that out of the way, let's take a look at a Python application. So notice here we have import subprocess. Does anyone here know what subprocess is? Never seen it before. Perfect. So subprocess is just a way of interfacing in with the command line interface of whatever operating system you're using. So it's a library that lets you interface directly with PowerShell or a terminal if you're in a Linux distro. So that is what we're doing here. We're importing a library that's doing all that for us. Now we have a function. So we're defining this function and we're calling it, hey, we're going to count the failed SSH logins. And we see try. Try is a way of us catching errors. We're going to say, hey, computer, try this. If it doesn't work, I don't want you to crash. I just want you to catch the error. If you don't try, accept your statements that you're running, it can cause issues and cause your application to just crash and you don't know why. And you spend a lot of time talking to ChatGPT about your life decisions and things like that. So don't want to do that. So result here, we're saying, hey, subprocess.run. And for anyone that's ever done anything in Linux, you may say, hey, Brandon, this looks familiar. We're grepping something. Well, that means we're sorting some kind of file and we're looking for failed passwords. And we're looking at var log auth.log. Now, for Linux folks in here, you'll pick up right away, oh, that's the authentication logs. That's the default for Linux servers. And that's exactly what we're doing. Now, you see this std out equals subprocess.pipe. What that means is we are going to take whatever the output that is, and we're going to give it to our Python program. We're going to say we're going to run this command and then just give it back so the Python program can do whatever it needs to do with it. So you can start to see or imagine already, oh, this could be really powerful. I could automate or do something in PowerShell or something in Linux, in Bash, and then I could run other things against it. I can use any of these other libraries and manipulate it to get a certain result. For example, you could set something up or some automation to run a check with different vulnerabilities. Maybe a new vulnerability like log4j comes out and you're saying, well, there's an Nmap module for that. You could write a Python script that's going to go out and check and give a really nice report about every machine that is vulnerable, and maybe a little faster than running a full Tenable or Nessus scan. And we'll see the example usage down here. It will actually count and find out what the number of failed logins are. All right, let's look at another example. This time we're going to look at an Nmap tool. And there's a lot of different ways that we could parse Nmap. And this code's actually going to do it the hard way. We are going to import XML, etree, element tree as ET. This library is just built so that Python can make sense of what in the world an XML file is. And this is going to let us import XML. For if you've not used Nmap before, you can output things to a text file. can also output things to a formatted XML file. So this is our function. We're going to parse. We're going to say, hey, the tree is going to equal, we're going to parse with this library, parse whatever the file path here is. And then we're going to say the root of the tree equals, go ahead and get the root. This is a function that someone else has built inside this library. So this syntax is typical of how we access functions inside other applications. Then we're going to say, hey, look for all the ports. There's that for loop again. We're going to look for every port in root. That's this tree we created. We want to find all / port. And what that is going to do, we're going to give it an attribute of port ID. We're going to look at the state of the port, and we're going to say if the state is open. See how we're using all those different control structures together. If it's open, tell me what port's open. And that's what we're doing. So we're taking this Nmap file, instead of trying to read through all the XML or do something, we're quickly getting it together where we can find out what the port's open. And then for this, we are just doing example usage. The Nmap file is whatever the file path is and just parse. So multiple ways to do that. We did that with strings in this one. You could also do that with a list and go through the list. There's lots of ways to solve problems in Python. So that is a super fast rundown on Python syntax, some examples of where that syntax is used to a practical program. And we could just stop there and we could focus there. But what if we could take what we just wrote and we could make it even more fun? What if we could make it like those cool command line applications we see? What if I could make an application like Nmap where I could actually make a command line application with all the flags and all the accessibility that I like from command line applications and get that into my app, but do it in a way that I don't have to spend a lot of work because I have very limited time to do this, because programming generally is not a cybersecurity professional's full-time job. Enter this incredible library called Python Fire. And let me tell you, this library is lit. It is a library that is automatically going to generate command line interfaces from any Python code. And I really do mean any Python code. It's going to speed up our process of turning our apps to fully functional CLI implementations. And here's how it works. We start by importing Python Fire. Then we create a function. This function in our example is just going to be called hello. We're going to return hello name, and it's just going to format name. And then we're going to set it to run. This will create the entire command line application just based off anything we define as functions, which means anything that's a function in our application or even pre-existing Python files, we can add this library and turn any of these functions into a command line function we can take advantage of. So let's see what I mean by that. Let's look at this much longer example. So import socket. Socket is the way that Python interacts with TCP/IP protocol, which is typically how computers communicate packets of information. We're going to import Fire. We're going to create a port scanner. We are going to scan, and we're going to say self, just referring to itself. Start port equals 1, end port equals 1024. These are all the ports in our range. And then we have a definition for scanning the port. And then we're going to have the main, which is going to be target localhost, the start port and end port, the scanner, and it's going to go ahead and scan. And now, just utilizing this code, we have a port scanner that's much worse than Nmap that we could utilize. But it's a great example of how we would take something and utilize it to give us almost the same functionality. So now it will immediately start your local host. But if you dove into it, it could do much more. So let's look at that. So we run scan.py. There is all of our options. Gives us our flags. It generates the flags on the fly. We don't got to worry about any additional configuration. As long as you have a function for it, it creates the flag. So now we're going to go ahead and scan hackinglab.com, and we'll start to see that's what it looks like. We can actually see we get the ports back that are open and based off the flags. And if we wanted to change our starting port or end port or just scan one port, we could. Now, you may say, well, Brandon, that's great, but we got Nmap. So why would I use this? Well, you don't have to use this for creating your own port scanner. You could have just as easily created your own command line tool that runs very specific functions in Nmap. Nmap has over 600 scripts. Let me tell you, those scripts are not always the easiest syntactic wise, but sometimes you just need to scan for log4j, or you need to run something that's going to enumerate SMB or something else. You could quickly create your own command line application that's going to run your Nmap scan and then parse whatever the results are. And you didn't have to do much of anything other than import Python Fire, a little bit of code, but most of the code's already done. You're just taking advantage of what a lot of other people have done. Now, we could stop right there, and that would be pretty good by itself. But I did have a picture of it. So there's the full picture of all the ports. We could stop right there, but this opens up a whole lot of possibilities for us. We can now create command line applications very quickly with very little code and only knowing a little bit of Python, enough to be very dangerous, as one might say. And our key aspects whenever we're creating an application is what are our inputs, what's our processing, and what's our output. This last application, what were our inputs? Well, that was our target, our start port, and our end port. What did it do? What was the processing? It's going to go through and scan each port to see if it's open. What's the output? It's going to tell us if it's open or not. If you can get good at conceptualizing this aspect, you can write almost any small command line application, because almost every single one is going to follow this process. And even greater, most large programming, there's a lot of frameworks, but a lot of them still work off this process. Individual functions, individual classes, they're all based off what are you giving it, what's it doing with it, and what are you getting as a result? And it builds off of that. This is fundamental to building anything in computer science, but we can utilize that. So let's ask some other questions, because that sounds like fun. If we could describe this common problem we have, and we know what the solution is, right? We want to create a command line application to solve X problem. And the problem can be solved with code, but we're not programmers. We're cybersecurity people. Some of us are even scared of code and really don't like touching it. But if we know what we want and we can describe the pieces accurately, maybe there's something this fancy AI thing can do to help us along, create a tool, maybe in 30 seconds that would normally take us a couple hours. So what are the things we need to give the AI? Let's think about that. We need the inputs. We need the processing, what it needs to do. We need the outputs. Maybe tell it what the flags are, right? We want to be able, these are your flags. Specifically, these are the inputs I want. And tell it which libraries to use, like Python Fire. Because if you don't, you just let it'll pick for you. You don't want to do that. So let's go ahead and incorporate. Here's a problem. I need to parse Nmap scans that are running and put all the hosts from an XML file. And I want it to create a CLI application that's going to take in the input and outputs, and these words are very specific, a Word document with all active hosts detected on the network with its open ports. The CLI application should have several flags that allow me to pick what to name the new Word document, as well as where to place it, but also have defaults for the local directory. Use Python Fire as a library you use to perform these actions to keep the CLI app simple. Let's see what happens. So if we get very specific with what we're doing, we'll begin to see something very similar to what we just looked at before, that we would have spent a lot of time ourselves. We see that same thing for parsing XML files. And it'll give us a lot of code. And that looks great, but does it work? Generated 53 lines of code. This is what it gave us, right? So it used docx to import the document library. OS, which is a different version of subprocess that's going to let us do something. Importing Fire because we asked it to. So here we go. Here's a function it made for parsing XML files. It's going to prepare the Word document. It's going to find all the hosts, going to determine the output path. So because based off what we give it, I told it to let me pick, I use the default one. So it's going to figure out what it is. And the end, of course, it's going to run it. So what does that look like? If we ran this code, that took 30 seconds to write, by the way. Once we knew what we were getting, it will give us, all of a sudden, we have an almost professional looking CLI application for parsing Nmap files to make our day easier. We have positional arguments we can add. We have the specific flags. And if we run it, it will output a Word formatted document of everything we wanted it to do. Pretty impressive, right? I know it was a long way, but that was good, right? So summary, Python's a very powerful tool for cybersecurity automation. Extremely powerful. Libraries like Python Fire make it super easy to create tools and solve common cybersecurity headaches and problems. You would not believe the amount of times I've said, man, I wish I could grab this from, NetSpark or some other tool I'm using, or even Fortinet. Hey, Fortinet has an API. I wish I could grab this information about the traffic. You can. A lot of these companies all have APIs that you can connect to, grab the information, and format however you want. It's extremely powerful. And we don't got a lot of time, so we can use AI to help solve that problem and really make our job more productive and just really be amazing. You'll wow people because they'll think you are the best programmer in the world. And it's like, me and my friend GPT, I mean, we do a lot. So that is the presentation.